Hi everyone, this is Manas, your friend and tutor, and guys, in today's session we are going to take a look at cantilever beams, and specifically when it is loaded with a uniformly distributed load. Let's see how it behaves, how the slope and deflection changes, and particularly we are interested in calculating the slope and deflection at free ends of these two cases. Well, these two cases, the results of these two cases can only be derived or determined once you know this. So first of all, you need to have the slope equation, deflection equation for this very case, and then you can find the slope and deflection at free end, that is end B. Anyway, before going ahead, my suggestion to you would be to watch my previous two videos on deflection of beams, and you can find the link to those videos from the description down below. And if you want to take a look at some other videos on mechanics of solids, so there are a whole lot of topics in the form of simple stress and strain, thermal stresses, principal stresses. All of those topics have been covered, so do take a look. Anyway, so let's begin with today's lecture. Sabse pehla kaam, the first thing that we'll do, just take a look at this. The beam is something like this. It's a fixed beam, isn't it? Like this. W Newton per meter. Well, that's good. Now if I were to replace this UDL with a single point load, so just take a look at this. In 1 meter, the total load acting is W. So for L meters, the total load acting would be WL. Where? Centrally, isn't it? This is going to be WL. So just going by the equations of statics, if there is a load of WL in the downward direction, since this is the fixed support, so obviously there is going to be a reaction over here. This is also going to be WL. But that's not enough. This distance, by the way guys, this is L by 2. If this is L by 2, then in that case there is going to be a moment over here. This is the acting moment. How much? WL multiplied by L by 2. WL multiplied by L over 2. So this is going to work out as WL square by 2. Just take a look. This acting moment has a magnitude of WL square by 2 clockwise. So the reacting moment over here will have a magnitude again WL square by 2, but the nature is going to be in the anti-clockwise sense. That's it. Now let us try to make the free body diagram of this very case, and then we can obviously proceed. It's not going to be that hard, but there is a lot of mathematics, a lot of geometry, trigonometry. So many things are there. कहीं पे भी एक step में भी कहीं mistake हुआ तो सब गड़बड़ हो जाएगा. So you've got to be very careful. Even I've got to be very careful to do this. Okay, so let's begin. Let's make the free body diagram of this very cantilever. Here we go. So we are going to substitute this fixed support with a reaction and with a moment. Okay, a reacting moment to be very precise. Here we go. बिल्कुल सीधा में आ जाओ. ये आ गए. Okay. Just take a look. So this obviously is the uniformly distributed load. Magnitude you know very well. This is W newtons per meter. Okay, and that's L for you. And there is a reaction over here. The magnitude, as I've already told you, for L, this is going to be WL. So in the downward direction, it is WL, so which can be compensated, which can be balanced by this WL. But that's not enough. We need a reacting couple also. How much? I already told you this is going to be WL square over 2. Isn't it? Now, let us apply the method of sections. Yes, you heard that right. Method of sections. So what we'll try to do, guys, is we are going to take the section from over here, from the left hand side. Let's take this section from the left hand side and let us try to analyze the beam. And here we go. चलो फटाफट बनाते हैं. ये इतना सा हिस्सा बना लिया हम लोगों ने. बिंदास. यहाँ से section लिया है. So we take the section from the left hand side. So obviously this distance is x. So section अगर left से लिया, so bending moment is anti-clockwise over here. Okay. At this very point we need the value of bending moment. So this is mx. We know this is entire load in the downward direction is how much? For 1 meter it is W. For L meters it is going to be WL. WL in downward direction. So here if you remove the support, fixed support, this is going to be WL in the upward direction. And obviously you saw this. Okay, the entire load. If you have to replace this UDL with a point load, what will you do? This is going to be L by 2. This is going to be L by 2, and there is this fixed point. So WL multiplied by L by 2 will give you WL square by 2 in the clockwise sense. So in the reactive sense it is going to be anti-clockwise. Here it is. The magnitude is कहाँ लिखे हैं यार WL square by 2. Done. These are all the forces essentially acting. And have I missed out on something? UDL. Yes, how can I forget the UDL? W Newton per meter. थोड़ा स्पेस कम है क्योंकि इतने सारे केसेस कवर करने हैं. एंड यू नो केस 4 डिपेंड्स ऑन केस 3, केस 5 डिपेंड्स ऑन बोथ केस 4 and केस 3. So I cannot erase and go on because I will be requiring these results for the upcoming derivations or cases. चलो देखते हैं, कोई टेंशन नहीं है. डस्टर कहाँ? ये है. Just keep watching. In a very cool mind we are going to understand these things. Okay, let us try to simplify. Okay, so the first thing which we'll do, guys, we'll take the moment, and here we go. We're going to take the moment. You can obviously take the moment about any point. I'm going to take the moment about this very point. Okay, is equal to 0. Just take a look at this. Very interesting. Anti-clockwise plus. Smaller handwriting I'll use. Okay, forgive me. Then what else have we got? We've got this anti-clockwise WL square by 2. Okay, so this has been taken into account, WL square by 2. So anti-clockwise plus WL square over 2 and WL multiplied by this x clockwise. So minus WL multiplied by x. Anything else? If you watch, there is this UDL, isn't it? So we can actually convert this UDL into a sort of point load. Okay, so for 1 meter the load acting is W. So for L meters the load acting would be WL. So but here we have x meters, so let me just write x over here. So it is going to be WX in the downward sense, you can say, right? So WX, what is the nature? It is anti-clockwise, isn't it? Plus W into x multiplied by this much distance. Okay, this is the nature. This much distance, half of x, that is x by 2. I think we have pretty much covered up all the forces, all the moments. Let me just make a check. Done. WL square by 2. Okay, then WL into x. Okay, clockwise, that's why negative. And then we've got this UDL. We converted that UDL into a point load, and we did that. WX into x by 2. Yeah. Done. MX minus WL square by 2 plus WLX minus WX square by 2. Let me just make a check. अगर चेक नहीं किया ना और कहीं आगे मिस्टेक हो गया तो बड़ा दिक्कत है बॉस. Okay, so final moment equation is this: minus WL square by 2 plus WLX minus WX square by 2. इतने मच्छर कहाँ से आ जाते हैं यार, पता नहीं, सारे दरवाजे बंद है. ठीक है, तो इक्वेशन तो सही है, बस अब लगाना है हमारा स्लोप डिफ्लेक्शन फॉर्मूला. दैट इज दिस मोमेंट. Okay, moment at any cross section of the beam is equal to EI d2y by dx square, and that is exactly what we'll try to apply. Very interesting case. We'll see eventually. We'll complete the entire stuff. Okay, within half an hour, less than half an hour, in fact. Watch. Here we go. So, क्या करते हैं? Instead of writing this mx, let me straight away write this I y double dash. Y double dash stands for d2y by dx square, second order derivative. Y dash stands for dy by dx, and simply y is basically the deflection. Okay, here we go. So on integrating this, when you integrate this, you have this result: EI y dash is equal to minus WL square x, and that's it. Okay, and x has been introduced here. Plus there is already an x, so this will become x square by 2 minus w x cube. X square becomes x cube by 3. 3 multiplied by 2 becomes 6, and plus again there is a constant. Okay, just take a look at this. So we took this section from the left. Okay, so we basically picked up our origin over here, and this is the best way to proceed. Okay, I simply follow the orthodox way. ओरिजिन इधर रखो यार, इस तरफ बढ़ो तो प्लस. कई लोग ओरिजिन इसको मान लेते हैं और इस तरफ को प्लस मान लेते हैं. आई डोंट वांट टू फॉलो ऑल दोस थिंग्स, बट इट्स अप टू यू. अल्टीमेटली द रिजल्ट्स आर गोइंग टू बी सेम. मे बी यू विल हैव अ डिफरेंट साइन इन द स्लोप, डोंट वरी, बट दिस इज वेरी मच ऑर्थोडॉक्स. ओके, सो आगे बढ़ते हैं. एंड इफ दिस इज द ओरिजिन, यू जस्ट कंप्रेस दिस x. व्हेन यू पुट द वैल्यू ऑफ x इज इक्वल टू 0, वी नो वेरी वेल that the slope at this very point, the slope and deflection at this fixed point is going to be 0. We know this very well, isn't it? So y dash is going to be 0. If that is so, y dash is 0, x is 0, x is 0, x is 0, then C1 will also be equal to 0. Isn't it? So what we can do is we can again rewrite this equation. Let's say over here, EIY dash is equal to minus WL square x over 2 plus WL x square over 2 minus WX cube over 6. थोड़ा जगह बनाते हैं यार, इसमें उतना टेंशन लेने की ज़रूरत नहीं है, उसमें थोड़ा सा बस यही सारे रिजल्ट्स को मैनिपुलेट करना है और वहाँ पे वो फाइनल फॉर्मूला बन जाएगा. नॉट टू वरी, जस्ट कीप वॉचिंग, दिस इज प्योर मैथमेटिक्स. Okay, here we go. So this is basically the result or the equation of slope, right? Now on integrating this, we'll have the equation of deflection. And first of all, let me make a check. Always make a check and keep on checking them. कभी भी गलती हो सकती है. माइनस डब्ल्यू एल स्क्वायर एक्स बाई 2 प्लस डब्ल्यू एल एक्स स्क्वायर बाई 2 माइनस डब्ल्यू एक्स क्यूब बाई 6. बिंदास, एक नंबर, सही चल रहा है. नाउ व्हेन यू ट्राई टू इंटीग्रेट दिस, व्हाट विल हैपन? लेट्स सी व्हाट हैपेंस. ओके, यहां पे करते हैं. सो दिस विल बिकम ई आई वाई इज इक्वल टू, how to proceed? WL square by 2. So this x will become x square by 2, and 2 multiplied by 2 is 4. So WL square x square by 4. Here we go. किधर गया नीला? Minus WL square x square whole divided by 4. X square by 2, right? 2 is 4 plus. अब इसको देखते हैं. What will happen? X square will become x cube by 3. Isn't it? 3 2 is 6. So WL x cube by 6 plus WL x cube over 6. Got to be very careful. कहीं पे भी मिस्टेक हो सकता है भैया, बहुत ध्यान से देखना है. तो WX, ये तो बहुत सिंपल है. x पावर 4 by 4, 4 into 6 is 24. So WX power 4 minus this will become WX power 4 whole divided by 24, and obviously you will have a new constant C2, and to get the value of this constant, what you can do is x is equal to 0. You know, at the fixed end the slope and deflection are 0. So for x is equal to 0, the deflection is also going to be 0. If that is so, 0 0 0, this entirely 0. Y is also 0. C2 will also work out as 0. So you have the final equation of deflection. लिखते हैं यार, कहाँ टेंशन है. So we've got the final deflection equations. Here we go. क्या आया ये E I Y? यार E I को इस तरफ, you can shift E I over here also. Okay, I'm writing it in this fashion. Minus W L square x square over 4 plus W L x cube over 6 minus W x power 4 divided by 24. So this is the result, and this is an extremely important result, let me tell you. But how to proceed now? What we want is the magnitude of slope and deflection at the free end. Okay, just a second, let me check. Time कितना हो गया इसमें? 15 minutes, more than 15 minutes. Okay, anyway, so slope and deflection. Slope किधर निकालना है? slope free end पे. We need to work out the slope at the free end. What is the free end? That is B. So the thing which we need to calculate is, let me tell you, you need to work out the slope at point P. Okay, very interesting. Obviously this is going to bend in this fashion, right? So what is the slope at the final point or the free end? Well, that is something that we need to work out. Just think about this. If the beam is initially like this, so finally it is going to bend like this. So if you just, this is end B, isn't it? This is A and that's B. Let's say if this is B, let's say this is B dash. So let's say this is B dash. Whatever the tangent is, whatever the angle that tangent makes, that is the slope. And this is exactly what we need to work out. यही तो पता लगाना है. कैसे पता लगाएंगे यार? That is also very easy. तो जरा देखते जाएं. बहुत ही आसान है. टेंशन लेने की बिल्कुल ज़रूरत नहीं है. तो ये देखिए कहाँ गया हमारा स्लोप इक्वेशन. ये है स्लोप इक्वेशन. बिल्कुल यहाँ पे पुट करना है. आपको b पे निकालना है तो जाहिर सी बात है आपको x का वैल्यू, द वैल्यू ऑफ x नीड्स टू बी पुट अप एज L. You compress x will become 0. That is, you are going to reach the origin. As you increase, keep on increasing the value of x, and when you reach this point, that is free end, x will be equal to L. If you put the value of x is equal to L into this equation, you are going to eventually get the value of deflection at the free end. बिंदास x को कितना रखने का, L रखने का, और आपका आंसर निकल के आएगा. कैसे करेंगे तो जरा देखिए. E I और यहाँ पे जो स्लोप लिखा y डैश लिखा है ना dy by dx वो स्लोप है. दैट इज स्लोप. व्हाट यू कैन राइट इज थीटा b. b बोले तो फ्री एंड. ओके, थीटा फ्री एंड, राइट, because b point is at the free end. That's why I have written it as theta b is equal to, now let us try to work out, WL square by 2 into L. So this is going to be minus WL cube minus WL cube by 6. नॉट 6, क्या लिख रहा हूँ मैं, बाई 2 है ये. ठीक है, प्लस WL x स्क्वायर बाई 2. जस्ट अ मिनट x स्क्वायर बाई 2. फाइन माइनस प्लस WL क्यूब बाई 2 प्लस WL क्यूब बाई 2. और क्या बचा है? What else? Minus WL cube by 6. Minus WL cube by 6. So you just need to apply a bit of mathematics. देखो WL cube can be taken as common, isn't it? So the stuff remaining inside the bracket would be minus half, plus half, and minus 1 by 6. So obviously these two fellows are going to cancel out. What shall remain is only this. This much will remain, and that's it. So we've got the deflection, not the deflection, but the slope. Slope तो मिल गया हमको. ठीक है, ये इतना मिल गया. ये दोनों तो कैंसिल हो गए ना. Let me just write this big and bold. Slope at the free end. Okay, free end is what? Slope at B, and which is going to work out as, which rather has already worked out as negative of W L cube over EI will be shifted 6 times of E and I. And that's it. That was how slope is supposed to be calculated. Now let us try to focus our attention on deflection at the free end. अब देखें deflection कैसे निकलेगा, तो वो भी बड़ा आसान है. deflection निकालने के लिए बच्चों हमको क्या करना है, what we need to do is you need to again put the value of x is equal to L. But in which equation? You need to put the value of x is equal to L, that is over here, into this equation. As soon as you do that, you are going to get a unique value of deflection. चलो करके देखते हैं. Let's try to do this deflection analysis. Deflection, and you have got to do this for the free end, and for free end you know that x is going to be equal to L. तो चलिए देखते हैं. हमको निकालना है deflection at the free end, that is at B is equal to how much? Okay, we don't know this. Let's try to work it out together. Now you just take a look at this equation. This is going to be E I Y what? YB, let's say, because it is the free end. थोड़ा और बड़ा कर लेते हैं यार इसको. Okay, so minus WL square, this is going to be minus WL power 4 whole divided by 4 plus L cube L, okay, plus WL power 4 again. This is going to be divided by 6 minus WL power 4 whole divided by 24. तो यहाँ पे जो फ्रैक्शन आ रहा है, the fraction that we need to encounter is 1 by 4 minus plus 1 by 6 minus 1 by 24. So the LCM is going to be 4 छक्के 24. तो यार 6 से जाएगा 24 आएगा. This is going to be 24. So this is 4 6 minus 6 6 4 plus 4. This is going to be minus 1. So this is going to be 6 minus 1 is minus 7. Minus 7 plus 4 is minus 3. Minus 3 by 24, that is 3 minus 1 by 8. Brilliant. Minus 1 by 8. Okay. So the final result is minus 1 by 8. So if we just do the math, this is going to be minus WL power 4 divided by 8. So what do you need? You need the deflection at the free end. The deflection at the free end, that's it. And that, in fact, that free end is, by the way, P and B right here, and which is equal to, कितना आया था यार? 8 आया था. EI इधर shift हो जाएगा. EI will be shifted towards the denominator of the right hand side. And yes, that's it. Done. Minus WL power 4 over 8 EI. Done. So that's over. Deflection analysis, we finished successfully. Okay, now we need to take a look at case 4 and case 5. ये भी थोड़ा सा इंटरेस्टिंग है, और इसमें जितने भी रिजल्ट्स यहाँ पे हुए हैं ना, उन सबको हमको वहाँ पे यूज करना है. कैसे करना है, चलो देखते हैं. So now let us talk about case 4. So we've got a portion of the beam is loaded with a uniformly distributed load. Well, for a distance A, span A, for this cantilever beam. Okay, बस इतना सा portion में है UDL. अब कैसे? How we need to work it out? Just take a look. Very interesting case. And let me make a line diagram rather. फटाफट. This way. So initially, that's the initial position, isn't it? That's the initial position. But finally, what will happen? After it is loaded, what will happen? It is obviously going to bend. And bend in this fashion. Let me just show that to you. क्या कलर यूज करें यार? पर्पल और ये यूज करें क्या? चलो ये यूज करते हैं. So first of all, there is going to be a bend in this fashion. Okay, an elastic bend you can say. And then, since there is no load, absolutely no load after this UDL, once you reach here, that is the end of the elastic curve. And from here on, it's absolutely straight. It's absolutely straight. Done. So basically what you've got is, you've got two profiles. You've got a curve over here, and you've got a line at this point. Okay, so this is point A, that's point B. If that's point B, let's say B has shifted to B dash, and that's point C. C has shifted to C dash. And what we can do is we can do some construction. Let's say this is theta, and let's say this is point D. Right? This is the same analysis which we had actually carried out in the previous case also. That was case 2. Okay, remember. Okay, so how to proceed? What we want is, we want the slope and deflection. We want theta and y for free end. Okay, so we are limiting our analysis to only the free end. We want to know the slope and deflection at the free end. How to approach? Now these results are really going to help us. Just we need to refer them. And कैसे करें? तो जरा यहाँ पे ध्यान से देखिए. What do we want? We want the slope at free end, isn't it? So slope at free end, that is equal to slope at B dash. Yes, quite true. Slope at B dash, isn't it? Which again, this entirely is a line. So whatever the slope at B dash is, it is equal to the slope of the line. You can say that. Okay, slope of the line. The line starts where? The line starts at C dash, isn't it? So that is also equal to the slope of at C dash. Now C dash is basically a point. C dash border है समझ लो, सरहद है, right? So C dash is the point which is being shared by the curve as well as the line. So whatever slope this curve has at C dash, that same slope will be of this line. Listen to this very carefully once again. Now this entirely is a profile like this, and then you've got a straight line. This is the intermediate point C dash. So whatever the slope at C dash of the curve is, that will be the slope of the line also. And this is the same case which we had taken up in case 2, right? So चलो करते हैं यार, कहाँ दिक्कत है? ये देखिए, just take a look at this. Just consider only this much portion. Okay, just forget as if there is nothing beyond C. We are talking only until we reach here, that is point C. Okay, this is fully loaded. So here we had B, there we are having C, let's say. right? Forget about any portion of the beam beyond C. If that is the case, here it was L, now it is going to be A. So what was the value of slope? It was equal to WL cube over 6EI when the entire length was L. But here the entire length is A. So what we'll do is we'll replace this L by A. So this is going to become minus WL A power cube 3 divided by 6EI. So this is going to be minus W A power 3 minus W A cube upon 3EI. And that's a very important and a brilliant result, isn't it? Now that's done. स्लोप भाई मतलब सी डैश पे जितना भी स्लोप होगा ये लाइन का भी उतना ही स्लोप होगा, लाइन का जितना स्लोप होगा भाई पॉइंट बी डैश पे भी उतना ही होगा. तो सी डैश पे कितना स्लोप है आपको पता है यहाँ पे, ठीक है, यहाँ पे कितना स्लोप है फ्री एंड पे. तो देखिए आप भूल जाइए कि यहाँ से यहाँ तक कुछ है, forget about it, right? And that's exactly what we've done. So we've replaced this L by A and that's the result. Okay, so this is basically one way of looking at it. Now what to do? Now that we've got the value of slope, how to go ahead? Here we go. सब बनेगा देखिए. As far as deflection is concerned, just take a look at this. This is the deflection at the free end, isn't it? Just think as if there is nothing beyond this point, nothing beyond this point. So the deflection right here, deflection at C will be equal to the deflection at B. So what is the deflection at B? That is WL power 4 upon ATI. What was the length of the beam before this B? That was L. What was the length of the beam before this C? That is L. What you need to do is replace this L by A. That is the first thing. That is going to be this deflection C dash. Now what we want is, we want the deflection at the free end. And by the way, this free end is nothing but deflection at B, which is nothing but a sum of BD plus DB dash. That is nothing. BD is equal to CC dash. It's quite obvious. CC dash plus DB dash. So your objective right now is to work out the values of CC dash and DB dash. Can you do that? Well, yes, you can do that. Once again, I'm telling you, you forget any portion beyond this C or towards the right of C. If that is so, the length over here is A, the length of the beam here is L. In that case, if the length is L, the deflection is WL power 4 upon ATI. If the length is A, only focus here, then the deflection is going to be WA power 4 upon ATI. In that case, here will be, इधर लिखते ना, WA power 4 upon 8 times of EI. और यार यहाँ पे लगना है माइनस का चिन्ह, नेगेटिव साइन. Now, what about DB dash? Can you work it out? Just a bit of math, a pinch of trigonometry, and here we go. Just take a look at this. This much portion, that's A, and this is going to be L minus A, isn't it? That's L minus A. What do you want? You want DB dash. So what, you can apply tan theta. Tan theta is equal to opposite, that is DB dash, over base, that is L minus A. So you want DB dash. DB dash is equal to L minus A times of tan theta, and you know very well that theta is extremely small, isn't it? So L minus A times of theta, right? So theta what? Theta line, isn't it? How much is theta line? You know that. It's minus WA cube upon 3EI. कुछ mistake किया क्या? It's not 3EI, it's 6EI. Let me make this correction. It's not 3EI, rather it's 6EI. थोड़ा सा छोटा सा मिस्टेक हो जाता है, क्षमा करें, हो जाता है. इतना सारा मैथमेटिक्स जब लिखता है ना बंदा, हो जाते हैं मिस्टेक्स are bound to happen. Well, we have to avoid them. Anyway, so ये theta line कितना है? WA cube upon 6EI. So just write this. This is going to be L minus A, and theta line, well, that is minus, just put a negative sign rather, equal to negative sign WA cube upon 6EI. Done, right? So here we go. Just put this value over here, a negative sign, and you have this result. L minus A W A cube over 6EI. Yeah, over. So these were the two results. Let's enclose this into a box. Slope and deflection at the free end for a cantilever beam having uniformly distributed load for a certain span length, that is A, from the fixed support. अब ये वाला केस देखते हैं. यहाँ पे फ्री सपोर्ट से, यहाँ पे जो फ्री एंड है वहाँ से यूडीएल है A दूरी तक. अब इसको कैसे वर्कआउट करेंगे यार? यहाँ पे लगेगा थोड़ा झोल झाल करना पड़ेगा. Just take a look at this. What you need to do is you can modify this figure. Let me show what needs to be done. नीला किधर गया? Just take a look. Again a very interesting case. Okay. So that's the UDL we have. Right? Let us spread this. This is the intermediate point. Let us spread this. So you have added more UDL. So in order to maintain equilibrium, in order to maintain that same balance, what you need to do is you need to add UDL from the downward direction also. So basically what we are doing is this minus this in the downward direction, this entirely in the downward direction minus this in the upward direction will give you this. And this difference has to be done for both slope as well as deflection. कैसे करना है बताता हूँ, ध्यान से देखें. ठीक है? Okay. Slope analysis सबसे पहले कर लेते हैं. Let's do for slope. कहाँ करें वही तो मैं सोच रहा हूँ. If this is L, so obviously this much is going to be L minus A. So let's do this for slope first. Slope at the free end. When we talk about free end, we are talking about end B because that's free. Right? अब कैसे करेंगे? So just take a look at this. अगर पूरा का पूरा UDL है, if there is entirely UDL on the total length of the cantilever, in that case the slope is going to be WL cube upon 6EI, isn't it? Right? So that's going to be WL cube upon 6EI. Just deal with this in magnitude wise. Right now we are dealing with it in magnitude wise. Then you've got this. Where? In the upward direction. So you already have this result in the downward direction. For the downward direction we have this result. So for the upward direction that will also be valid. So what you need to do is here just take a look. WA cube over 6EI. That A was here. But here we are having L minus A. So that A will be replaced by L minus A. Once again, थोड़ा सा confusing है, ध्यान से देखो यार. यहाँ पे this portion is A and here this portion is L minus A. So if this was A, then the slope was A cube. But if it is L minus A, then here we need to write L minus A and cube of it. That's it. So minus of WA cube, not A cube, W L minus A cube divided by 6EI. And just put a bracket. Okay, put a bracket equal to with a negative sign. Let me just make a check. चेक नहीं करेंगे तो बहुत दिक्कत है. WL cube by 6EI minus WL minus A का cube upon, हाँ बस हो गया. स्लोप का काम तो हो गया, काम तमाम हो गया. Let us talk about deflection. Deflection at the free end. What we want is deflection at the free end, and we know that free end is NB. So how can that be worked out? तो वहाँ पे भी दोनों माइनस करना है. इसका डिफ्लेक्शन कितना है? This load acting in the downward direction minus WL power 4 upon 8EI. तो पहले तो magnitude wise लिखते हैं. Let us first of all write this in the magnitude wise sense. WL power 4 upon 8EI minus. अब अंदर का क्या हिसाब किताब रहेगा जरा ये देखते हैं. Just take a look at this. This upper portion is over. Okay, this downward portion. Okay, load acting in the upward direction this way. So this is pretty much similar. This one and this much. this much, this portion is pretty much similar. Okay, the only difference being this is acting in the downward direction, this is acting in the upward direction. So all these results are going to be valid here. If you watch carefully, now the UDL is, here it is L minus A and here it is A. This much portion is A and that's L minus A. Just take a look at this result. This is what we'll be using. Okay, WA power 4 upon ATI. A was here. Now here we have L minus A. So this A will be replaced by L minus A. This A will also be replaced by L minus A. Similarly, this much portion is L minus A. So we have L minus A over here. But this much portion here, we have it as A. So this, in place of writing this L minus A, we'll write A. Once again, थोड़ा सा confusion हो सकता है, फिर से करते हैं इसको. देखिए हम क्या कर रहे हैं, हम लोग ये वाले पोर्शन की बात कर रहे हैं. ये जो है ना नीचे से जो लग रहा है ना, उस पोर्शन की बात कर रहे हैं. We are talking about this portion. So this length is that's L minus A and the remaining stuff is A, isn't it? तो यहाँ पे जब A है, लेकिन यहाँ पे L minus A है, and here we have L minus A and this portion is A. Swap everything. Replace A by L minus A. A will become L minus A and to the power 3, and L minus A will become A. That's it. Do the replacement, do the substitution, and that is going to give you your final result. Here we go. Where are we? Here. WA power 4. Replace A by L minus A. That is L minus A to the power 4 whole divided by 8 E I plus. Just assume as if you've taken minus as common and then you have written this result. Isn't it? Just take it like this. Plus L minus A, replace it by A. W. A cube, replace it by L minus A and its cube divided by 6 times of E I. And yeah, that's it. That's your deflection at the free end. So these were basically the results that we were interested in. हो गया, पूरा हो गया. Done. नीचे डिस्क्रिप्शन में आपको इसका नोट्स भी मिल जाएगा, वो भी मैं प्रोवाइड कर दूंगा. ठीक है, कैम स्कैनर से फोटो लेना है यार, PDF डाल देंगे, कोई दिक्कत नहीं है. So guys, that was all for today. In the next session, we are going to talk about double integration method applied to a simply supported beam, and we'll try to see how the slope and deflection changes, okay, across the beam. Anyway, that was all for today. I'll see you again in the next video. Until then, take care, have a nice day, keep learning, keep watching. Thank you.